Hello there. You can use an electrospinning machine like the one you see here to make ultra small diameter fibers. You take the polymer solution and use a syringe pump to deliver it to the needle tip where high voltage is applied. Under the intense electric field, polymer fibers are charged and stretched while it travels through the air to the rotating collector. With an apparatus like this, you can conduct a lot of interesting research. Let's take a look at the collector assembly. The collector is detachable. You can install it by aligning the gears and dropping it in place. This cover plate being installed here gathers the stray fibers. It's nice to have because it makes it easier to clean later. You can move the collector back and forth or position it as you like. The collector rotation speed is adjustable. You use the syringe pump to deliver a small amount of the polymer at a consistent rate for electrospinning. In this particular case, we're using a 1cc syringe with the adapter. The plunger end goes in first, then you lock the syringe in place. Connect the high voltage clip to the needle. Before you touch any high voltage points, always check and make sure the high voltage power supply is off. This is the controller for the syringe pump and collector assembly. The top section gives you control over the syringe pump. The middle is where you adjust the collector rotation. The collector assembly is mounted on a linear stage, so you can position it anywhere for fiber collection. LabMate is an adjustable high voltage power supply, and you can control the output in either constant voltage mode or constant current mode. It is compact, lightweight, and versatile. This particular model you're looking at can output up to 30 kilovolts and 0.4 milliamps. You will also find that our benchtop high voltage power supply is highly integrated for laboratory use. It is designed and built specifically for your convenience. You are now going to see the electrospinning of PVP fibers. The solvent is water and ethanol mixture at 60% of total weight. From start to finish, the whole process took 30 minutes. High voltage is the driving force behind this fabrication process, and it does not require any significant current output. The high voltage power supply on this machine have both voltage and current controls, so we set the high voltage output to 24 kilovolts since that gave a good consistent result. The current output was set at 100 microamps to serve as a current limit. Under normal electrospinning conditions, it operates in a constant voltage mode and keeps the output voltage regulated at 24 kilovolts. The current limit is a safety feature in this case, and if something were to happen, like an unexpected arcing or discharges, then it will automatically switch to current control mode and limit the output to 100 microamps by lowering the output voltage as necessary. This is a great way to protect the user as well as the equipment. If you see arcing or hear noises, make sure to turn off the high voltage power supply as quickly as possible to prevent permanent damages to the electronics. Now that the process is complete, let us take a look at the electrospun fibers. The white PVP fibers are nicely deposited on the collector. It comes off the collector assembly quite easily. It is a continuous white sheet that is fibrous. The sheet is soft to the touch, but feels durable. The weight of this sheet is 0.35 grams, so it is pretty lightweight. Electrospinning experiments are fun and interesting. I hope you enjoyed the video. Come visit us at sprucescience.com.